Hi everyone and welcome to the learning curve. In this video we'll be going through integration by parts, and I'll be using two common type of integration by parts problems to illustrate how to integrate by parts. Now, to integrate this first problem, integral of 2x e to the x with respect to x, we're going to first rewrite this problem for simplicity. So I'm going to rewrite this as this is equal to 2. I'm going to pull out the constant, which is one of the things we're allowed to do with these kinds of problems where you have a constant multiplied by variables. So we pull out the constant term of 2 in front of the integration sign. So I have 2 by the integral of x e to the x. The reason for doing this is to really simplify the integral. So the integral here is x e to the x. So this is really just a re-expression of the original problem. Integral of 2x e to the x with respect to x can be expressed as 2, pulling out this constant and placing it in front of the integral sign. So we have 2 by the integral of the product x e to the x with respect to x. Integration by parts is an extremely powerful tool of integration for products. So our task now is to integrate x e to the x, and eventually we will multiply back the answer by the 2, the constant of 2 that we pulled in front of the integration sign. So our task, as I indicated, is to integrate x e to the x. And so what we're going to do is to identify the term that is harder to integrate between x and e to the x. And here the term that is harder to integrate, we're going to assign the term that is harder to integrate as u. So the term harder to integrate here is this algebraic expression x. So we call xu, whichever term in the product is harder to integrate, we assign it as u, and the other term we assign as dv. Now the integral can work regardless. In many cases the integral can work even if the assignment was the other way around, as in dv for x and u for e to the x. In many cases the integral can work out very simply regardless of the order in which the terms in the product are assigned as u or dv. But for simplicity, it's best to identify the term that is harder to integrate and call it u, and then the other term you call it dv. So what we now have is u being equal to x and dv is equal to e raised to the power of x. So what I will use this to do, for u equal x, I will find du. I will differentiate with respect to x here. So du dx, which is finding the derivative of the x here with respect to x. The derivative of x with respect to x is of course going to be 1. So in effect, differentiating 1x gives us 1. So if I rewrite this, this becomes du equal 1 dx. That is, if I multiply both sides of the equation here by dx to get rid of the denominator, I will get du alone on this side because the dx cancels, and 1 dx on the other side of the equation here. So I get du equal 1 dx, which of course can further be written as simply du equal dx. Right? And that is because 1 multiplied by dx is just dx based on the identity property. So now we have u and we have du. We also have dv here, which we assigned as e to the x. So from dv, I will compute v by integrating dv. So at all times when you're integrating by parts, whatever term you assigned as u, you will need to differentiate it to get du, and whatever term you assigned as dv, you will integrate it to get v. So here I'm integrating dv to get v. Of course, this is also with respect to x. So what I would have here is v equal the integral of e to the x with respect to x, and this would basically work out to v being equal to e to the x, because the integral of e to the x is e to the x divided by the coefficient of the x in the power, which is 1. So any term divided by 1 is going to leave that term unchanged. So the integral of e to the x is indeed e to the x. Now that we have differentiated u to get du, and we have integrated dv to get v, we are now ready to integrate. So the integral of 2x e to the x with respect to x, which is what the dx here means, would be equal to uv minus the integral of v du. That's uv minus the integral of v du. So now we're going to substitute based on the values that we have from here. So u was assigned as x, so I'm going to just put x there in bracket representing the u right here. Then we're going to substitute for v. We worked out v by integrating dv. Integral of e to the x gave us back e to the x, so I'm substituting v here as e to the x minus the integral of v, and the integral of v here is going to be e to the x. Sorry, the integral v is e to the x, so we have integral e to the x, so I'm going to put that in bracket as well, and du is just equal to 1 dx, right? So that's 1 dx, so 1 dx, or simply dx. So this can therefore be rewritten as x e to the x. When we multiply x by e to the x, we get x e to the x minus the integral of, now e to the x multiplied by 1 is going to be e to the x, and we are integrating with respect to x. So we end up with x e to the x minus the integral of e to the x, and the integral of e to the x, as I discussed earlier, gives us e to the x. And since we are integrating with respect to x, we're going to add the constant of integration, which is k. We're integrating with respect to x, and it is an indefinite integral. More importantly, it's an indefinite integral because there are no upper and lower bound on the integration sign. So we have to add the constant of integration once we are carrying out an indefinite integral. So my answer is this: x e to the x minus e to the x plus the constant of integration, which is k. And what I can do here is that because e to the x is common to both expressions here, x e to the x and minus e to the x, I can factor out the common term e to the x. So when I factor out e to the x here, e to the x divided into x e to the x will leave us with x, and e to the x divided into negative e to the x is going to give us negative 1 plus the constant of integration, which is k, and that is our final answer. So the integral of 2x e to the x with respect to x would be e to the x times x minus 1 plus the constant of integration, which is k. And the only other thing I need to do now to square this off fully, this is the final answer for the integral here. But to complete this entire process, I need to recall that we had pulled out 2 in front of the integral here. So I just need to multiply this answer by 2. So the final answer is 2e to the x minus 1, plus the constant of integration, which is k, and that is the final answer overall. So the integral of 2x e to the x is equal to 2 e to the x into x minus 1 plus the constant of integration, which is k. So this answer here would have represented the integral for x e to the x. This answer here is the integral for x e to the x, this portion. But because we had pulled out 2 in front of the integration sign, we have to multiply back the answer for the integral of x e to the x by 2. So we get 2 e to the x minus 1, plus the constant of integration, which is k, and that is the final overall answer. Well, let's look at another integral here. We're going to look at the integral of x sine x with respect to x. And again, the conventional approach to take when integrating products using the method of integration by parts, which is very potent method of integrating by parts, is to assign u as the term in the product which is harder to integrate. The terms I have in the product here are x and sine x, and we're going to assign one of these terms as u and the other as dv. Harder term to integrate here would be the x, so we assign it as u, and we'll assign the other term in the product as dv. So here I have u being equal to x, and whatever term is assigned as x, whatever term is assigned as u, we are going to differentiate it. Of course, this is with respect to x, so du dx means that we're differentiating the function u with respect to x. And when I differentiate this function here, x, I will get 1. And when we re-express this in terms of du, and du would really be equal to 1 dx, or simply dx. We also assigned dv as sine x. Yes, so we assign dv as the sine of x. And since we assign dv as a sine of x, we now need to find v. So to find v, v is equal to the integral of dv. So whatever term in the product you assigned as u, you differentiate it to get du. And whatever term you assign as dv in the product, you integrate it to get v. That's the critical first set of steps to take when you're integrating by parts. And as I indicated, integration by parts is a potent method for integrating products. So here this becomes v equal the integral of dv, which is the integral of sine x, right? And of course, this is taking place with respect to x. Remember, we assign dv as sine x. When we integrate sine x, we're going to get negative cosine x. Yes, we get negative cosine x here. That's the integral of sine x, negative cosine x. So now that I have u, du, dv, and v, we're now ready to integrate. So therefore, the integral of x sine x dx, meaning with respect to x, we know would be equal to uv minus the integral of v du. So this is the integration formula for integration by parts, uv minus the integral of v du. So let us now substitute based on the values that we came up with here. So u is x based on the assignment that was done at the beginning of the problem. V was found to be negative cosine x, and this would be minus the integral of, again, v, which is negative cosine x, which I'm going to put in bracket here, negative cosine x, multiplied by du, where we found du earlier to simply be 1, and this is with respect to x. So this becomes, by simplification, this becomes negative x cosine x. That is, when I multiply x and negative cosine x, the entire product can be condensed into negative x cosine x. Because of the double negative sign here, this is going to become positive, but let me introduce one other step here. So this is going to become simply minus the integral of cos x, because negative cos x, because negative cos x multiplied by 1 is just going to leave us with negative cos x, and of course the integral is with respect to x. So this becomes negative x cosine x, and the negative multiplied by negative is positive, so this will become plus the integral of cos x with respect to x. So this is shaping up very nicely. So I now have the negative x cos x plus the integral of cos x. So all we need to do now is to integrate cos x here. When we integrate cos x, we're going to get sin x. And of course, now that I've integrated, there's no need to write back dx here after you've integrated. Then, because it's an indefinite integral, which means that there are no bounds on the integration sign. Here, there are no upper and lower bound. We're going to add our constant of integration, which is k. So the integral of x sine x with respect to x works out to be negative x cos x plus sine x, of course, plus the constant of integration, which is k. And that is the answer for this problem. Thank you very much for your time. I hope you found this to be fun. Thank you. And I will see you soon with more problems and more illustrations in the learning of mathematics. Math is fun. Have a good one. See you soon.